So the first thing that we're going to be looking at in this section is we're going to be talking about what we mean by elementary functions. And these is just kind of a group of functions that we're going to use a lot. And then we're going to learn how to do transformations on those. All right. So to start with, we want to know how to construct the graph of each of these elementary functions. We have an identity function, square function, cube function, square root, cube root. Absolute value are the ones that we're going to be looking at. All right, so I'm going to go down here and we're going to just construct this first one is the identity function. And what we're going to do, the strategy we're going to take is we're going to make just table of values on this and then plot points. All right, so to begin with, the identity function, the reason we call that is because these things are identical. If you plug in the -2, you just get -2. You plug in -1, you just get -1, and so forth. So the table of values goes like this, and then we're going to plot these points. All right, so as I go through and plot the points, look like this. We go left 2, down 2. Just put your dots on each one, left 1, down 1, 0, 0, 1, 1, 2, 2. So that's how the identity functions graph looks like. It's just a straight line that goes through this group of points, right? So anywhere on this point, like this, for instance, would be the point -4, -4, x and y are identical to each other. All right, as we go through this, we'll talk a little bit about what the domain and range is. The domain is what x can be. So it's what we can plug in to this function. In this case, anything works. So we just say -infinity to infinity. We're just going to write these things in interval notation. The range is this way. The range is what can y be. So if you look at your graph, y takes on every single value there is because it goes on infinitely in both directions. So that range is also all real numbers, all right? And I'm going to write some of these things at the side. You could say, if you were doing the domain in set builder, you would say set of x, then you would say x is a real number. Now you can learn to write it this way. This E thing right there just means element of. And then this symbol here, the R with the double bar, can just be thought of as a real number. Okay, so that goes like that. All right, now if we go to the next thing, oh shit. Okay, so on the next one, what we'll look at is we're going to do what we call the squaring function. So what we're doing is taking these x values that I have given you, and then we're squaring this. We've done this before. So you're doing -2 to the second, which means that you're multiplying -2 times itself, so that would give +4. And you repeat the same thing. A lot of this stuff is easy enough to do in your head. So if you do -1 to the second, that becomes +1. 0 to the second is 0, and so forth. 1 to the second is 1, and then finally 2 to the second is 4. Okay, so we're going to do the same thing. We're just going to plot points. So this first point is left 2 up 4. Second point is left 1 up 1. 0, 0, 1, 1. 2, 4, so get your points plotted, and then that will be how the graph of the squaring function looks like. We call that a parabola. We've certainly talked about that before. Okay, the domain on this, again, is all real numbers. So x can be anything. You can square any number. There's not any number that you can think of that you're not allowed to multiply by itself twice. And then the range on this is a little bit different. The range would be the lowest value of y is 0 and then gets bigger. So we would say bracket 0 infinity for the range, because again, we're including the 0 on that, all right? If you wanted to write these things in set builder notation, again, you would just say set of x is a real number, would be your domain, and then your range, you would say set of y, then you would say y is greater than or equal to 0. Okay, so you want to be able to write that in both ways. All right, and you want to be able to construct these things very quickly. These things can also be done very easily on your graphing calculator, but you want to be able to be flexible when you do this. So this first one, I just put in y equals x, zoom 6. That's the graph we got. Second one, y equals x to the second. Whoops. Okay, so you put that in like that. Oh, what's wrong with me? There we go. Okay, and gives you that same graph, right? But you want to understand the mathematics behind that and the arithmetic that you're doing. All right, so on the next page, we'll go to a cubic function. And we're going to do the same thing on this. We're going to raise each number to the third power. So if we do negative 2 to the third, that is negative 2 multiplied out 3 times. If you multiply out 3 negatives, what do you get? Okay, you get a negative. So that would be 2 times 2 is 4, 4 times 2 is 8. So that's negative 8. And then if you do negative 1 to the third, again, it's negative 1 multiplied out 3 times. That's going to give you negative 1. And then 0 to the third is 0, of course. And 1 to the third is 1. And then finally, 2 to the third, multiply out the 2 3 times, that's going to give you 8. Okay, so those are the points you'll get. And then you just go left 2, down 8 for the first point, left 1, down 1 for the second, 0, 0, right 1, up 1, right 2, up 8, like that. Okay, so we got that, and that is a curve that kind of looks like that. Okay, as far as the domain on this, x can be anything, so there's no number that you cannot multiply out 3 times. So that domain's all real numbers, so we write it that way. Or we could write set of x such that x is any real number. And then the range is the y, so it's infinite, okay? Y can be 0, it can be positive, it can be negative. So it ranges through every real number. So with this, we say interval negative infinity to infinity. Set builder, we say set of y. Y is a real number. Okay, so you can write it like that. Okay, next one. Square root, we've learned how to do this before. So the key thing is I left this blank on purpose is because you want to understand that when you do a square root, you can't do a square root of a negative number. That doesn't make any sense. The square root of 0 is 0 because 0 squared is 0. And then you can do square roots of positive numbers are okay. So I'm going to start at 0. And then I'm going to pick numbers I know square roots of. I know the square root of 1. I don't know the square root of 2 because that's decimals, so I'm going to bypass that. Same thing with root 3. I go on to root 4 because I know that. And then I'll go to 9, and then that's good enough. So what I'm doing is square root of 0, which is 0. Square root of 1, which is 1. Square root of 4 is 2. And square root of 9 is 3, like that. Okay, then I plot the points. So I've got 0, 0, 1, 1, 4, 2, and then I'll extend out to 9 and go up to 3. Okay, so that goes like that. That's how the square root function looks. Okay, as far as the domain goes, now the domain you have to start with 0, and then you get infinitely bigger. So x can be any number that's either positive or 0. The range is the same way, that your lowest value of y is 0, and then the y values get bigger forever. It looks like it levels up, but it really never doesn't. It just gets bigger and bigger at a slower rate. So that would go like that. Okay, you could also write the domain like this. You could say set of x is greater than or equal to 0. And you could write the range as set of, whoops, you want to always write the range with a y value. So we can say set of y greater than or equal to 0. Okay, like that. All right. Okay, so now we're going to move to the cube root function. And again, this one, we're only going to use numbers that we can do cube roots of. So you want to think about this a little bit. It's okay to do a cube root of a negative number. It's okay to do cube root of 0. But it's okay to do a cube root of a positive number. So what you're trying to do is think backwards. What would you get if you took like -2 and multiplied it out 3 times? Well, you get -8. So we're going to use -8. If you did -1 to the third, you would get -1. So we're going to use that. And if you did 0 to the third, you would get 1. God, that's a bad mistake, teacher, okay? 0 to the third is 0. I do stupid things like that sometimes. Okay, so that's 0. And then 1 to the third is 1. And then 2 to the third, of course, would give 8. So what I'm doing is I'm figuring out good numbers to use so I don't get any decimals here. So if I do the third root of -8, that's -2. If I do the third root of -1, that's -1. If I do the third root of 0, that's 0. And if I do the third root of 1, that's 1. And the third root of 8 is going to be 2. All right. So let's go ahead and let's plot those points. I'll also show you how you can do different roots on your calculator. And this one, we're going to go left 8, down 2. That's the first point. Then left 1, down 1. 0, 0, 1, 1, over 8 up 2. So the graph of the cube root function looks like this. Okay, all right. Now the domain on this is going to be all real numbers. Oh God, somebody's mowing the yard. Okay, I don't know if you guys can hear that or not. Somebody next door is mowing the yard. All right, so let's see. Domain would be all real numbers. Range would also be all real numbers. All right, so we have that. If you were to write this in set builder, you would say set of x is real. And you would say set of y is real. Okay, so let me show you a couple things on the graphing calculator also that's worth knowing. So if you want to check this out on your calculator, okay, I was going to show you where the cube root is. So under your math button, if you press math, you'll see this option 4 is a cube root. Okay, so that's worth knowing. So if you did the cube root, you just go like that. If you wanted to do the cube root of -8, you do that. Okay, again, one more time, math, option 4, then you can put the cube root of any number in. Now, see if you do something like cube root of -3, you get a bunch of decimals. Okay, so that's where you do that. All right. Okay, moving to the next thing, just going to do one more and then that'll end the video here. So what I'm going to do on this one is absolute value of x. I think we've done that before. So remember, it works like this. If you do an absolute value of a negative number, that's just positive. Because what it really is it's the distance this number is from 0. The number -8 is 8 units from 0. And distance is always positive. Absolute value of 0, the meaning of that is how far is 0 from itself? Well, it's 0 units. If you had absolute value of 7, that just means how far is 7 from 0? That's 7. That's why you get positive values. So I just do the absolute value. Now, you can do every one of these in your head. You don't have to write all this out. But you're doing the absolute value of each one of these numbers. So you end up getting these values. Okay, if you plot your points, you go left 2 up 2, left 1 up 1, 0, 0, 1, 1, 2, 2. Okay, so you want to get all your points on there, and then the shape is kind of like a V shape. So it goes like that. You want to make sure you have that double arrow. That's important. If you don't have the double arrow, you're telling me that the graph stops. The graph doesn't stop. It goes on forever in both directions. That's why you want to put the double arrow on that then. Okay, well, the domain is all real numbers. You can take the absolute value of any number you want to, and you could write it as in either of these two ways. The range is the lowest value of y is 0. So see, that's your lowest value. Then it's going to get bigger forever. So you would say 0 infinity. Again, that includes the 0. And then you would say set of y. Y is a real number. Okay, so see, all these elementary functions, it's real helpful if you memorize what they look like. But you also want to know how to quickly construct these things with a table of values, okay? It's going to show you one more time. I think I've already done this, but the way you graph this is you go y equals, you go to math, and you go to number, so you move the cursor this way. ABS is right there, and you just put in the x like that, and if you graph that, that gives that absolute value function. Okay, you can always look at the table of values to look at numbers. So notice on this, it's just always given positive values except when you have 0. Okay, so that'll close off this part, and in the next part of the video, we'll look at what we call transformations.